Hi, this is section 7.3 on system of inequalities. So we want to sketch this inequality. What we want to do is write it in the form of y equals mx plus b so that we can graph, and then we shade because it's an inequality, not an equation. So let's start by solving for y. Subtract 4x. We get 3y is less than negative 4x plus 12. Divide by 3. And now we have y equals less than negative 4/3 x plus 4. So we know our slope is negative 4/3 and our y-intercept is 4. So we go to the graph, the coordinate plane, and we graph our y-intercept first. And then we use our slope, which is our rise, which is negative 4. And then our run is positive 3. So there's our second point. Right there. Down 4 over 3. Connect these. And because it's a less than, the rule is if it's less than or greater than, it's a dashed line. And if it's less than or equal to or greater than or equal to, it's a solid line. In this case, we have a dashed line. And then we got to determine whether we shade below or shade above. So I'm going to choose the origin as a point to test. You can choose any point, but the easiest point to test would be the origin. So substitute the origin into the equation. So if you do, you're going to get 0 less than negative 4/3 times 0 plus 4. That 0 is less than 4, which is a true statement. Because we got a true statement, that means this is part of the solution set. So therefore, we need to shade that side because it's true. So we're going to shade the bottom of the graph. Okay. Another way you could have determined is by, once you have it in slope-intercept form, if it's a less than, you shade below. If it's a greater than, you shade above. That's a shortcut. All right, for this one, let's see. For this one, it's a parabola that is shifted up 4 units. So we can create an XY table to get some points. Let's go with negative 2, negative 1, 0, 1, 2. If you substitute negative 2 in for x, you're going to get 4 plus 4, which is 8. If you substitute negative 1 in for x, you can get 1 plus 4, which is 5. 0 gives us 4, 1 gives us 5, and 2 gives us 8. So let's plot those points. Negative 2, 8 would be somewhere up here. Negative 1, 5 would be about there. 0, 4, 1, 5, 2, 8. So this is a solid line. So the curve is going to be solid. There we go. And now we got to figure out which direction to shade. I'm going to test the origin once again. That's my favorite point to test. If you substitute 0 for x and 0 for y, you get 0 plus 4 is greater than or equal to 0. 4 is greater than or equal to 0 is a true statement again. Because it's true, you have to shade the side that's where the origin is, and that would be the bottom, the below the graph. If it would have been a false statement, then you would have shaded inside the parabola. All right, for this one, we have two absolute value inequalities. So what that means, this first one, by definition, this is what this means. The absolute value of x less than c, c stands for a constant, means that you have negative c on the left, x in the middle, and c on the right. So that's just the definition of absolute value. So let's apply that definition to the top one. So if you do that, you're going to get negative 3 on the left, x plus 1 in the middle, positive 3 on the right. Now we can solve for x by subtracting 1. Should get negative 4 less than x less than 2. So you've gotten that. These are two vertical lines. You have, ignore that, you have x is greater than negative 4. Ignore that, you got x is less than 2. So this one here would be a vertical line at negative 4, dashed, This one here is a vertical line at positive 2, also dashed. And this is telling us that the solution set is all the values in between, so the shaded region. But I'm not going to shade yet because we still have a second inequality that we need to work on, so let's do that one now. So if you rewrite this in terms of its definition, you would get negative 4 on the left, y minus 2 in the middle, positive 4. Add 2 to solve for y. And you end up with this inequality. Those are horizontal lines. So we have two horizontal lines, one at negative 2 and one at 6. So here's the one at negative 2. And the one at positive 6 would be up here. And this is saying that the solution set is all the values that are in between negative 2 and 6. So that would be all of these values. Well, if you have all of that and then you have all of this, you'll keep overlap of two shadings. The overlap is going to be the rectangle in between. So let's go ahead and shade the rectangle in between. That is the solution set because that's where the two shadings overlap. Okay, for this one we have a circle centered at the origin and radius 5. So 5, 5, negative 5, negative 5. Let's draw that circle. It's kind of hard to draw. Let me try that one more time. All right, that's a little bit better. Okay, and then we have a linear equation. That's going to be, let's subtract x to both sides. You got y less than or equal to negative x minus 3. Your slope is negative 1 and your y-intercept is negative 3. So we got negative 3 here. You're going to go down 1 over 1. Your slope is negative 1 over 1. So the rise is negative 1, which means you go down 1 and then you go positive 1. And that is also a solid line. Okay, so there we go. So for the circle, let's determine the shading. I'm going to test the origin. So 0 plus 0 is less than 25. That is a true statement. So the circle is going to be shaded inside. Let's figure out which side of the line is going to be shaded, above or below. So let's try the origin yet again for the circle this time. For the line this time. If you plug in 0, 0, you're going to get 0 less than or equal to negative 0 minus 3. That would be 0 less than negative 3. That is a false statement. Whoops, I'm sorry. This should have been a true statement for the circle. It was true, but for the line, it's false. So for the circle, you're shading inside. For the line, you're shading outside or below. And so the overlap would be this region. So that's what I'm going to shade. You only want to shade the overlap of the two shadings. So the overlap of the two shadings will be that little region that's in blue. And that concludes this section.